Hey everyone, my name is Ethan. I am an undergraduate student at Brigham Young University, and I'm gonna share on music, specifically Spotify's algorithm and how we can make models with that. So some background, I'm studying marketing at BYU. There's a class in the marketing program that is a pre-PhD marketing research seminar. And basically what it is we just follow Richard's textbook all the way through and choose whatever project we want and then make a model based on that and build complexity in the model as we go along. You can take this class multiple times, so I've now taken it twice. The first time I took it, I did some work on multinomial logit models that I was really proud of, and then I went to StanCon last year, and through learning some stuff there, found out that I actually had severely misspecified my entire model, and a lot of my work was kind of moot. So I figured the best way of doing my second project was to share it all publicly at StanCon, and that way I can find out what I've done wrong. As I was deciding what project to do my second year in this class, I was talking with my friend Justin. Justin's this guy right here in the middle playing guitar. He is a local musician in Utah, where I study right now. I love going to live music. I've seen a lot of his stuff, and we started talking about just how hard it is for grassroots musicians to kind of get a following. There are a lot of reasons for that. One of the reasons is nowadays everyone streams music, right? It's harder to go to live events, and it's easier to just stream whatever music you want. The tricky thing is a lot of algorithms are kind of paradoxical for Spotify or Apple Music in that in order to get streams, you have to be popular. But in order to be popular, you have to have people listen to your music, which means you have to have ways of people finding it and streaming it. So it's tough for artists to become popular on Spotify. So we started asking, what are some ways that we can kind of, are there ways that we can improve that and just make songs inherently more popular? Are there any sort of variables that we can control there? And the question of interest that I ended up doing for this project was on one of these variables, which is collaboration. So having more than one artist on a song listed on Spotify. Does that, regardless of the popularity of a song or other artists, does that inherently increase popularity, having multiple artists? First, in order to understand that, we have to track a number of other variables that make songs popular, right? And there are a number of these that are really easily quantifiable, like the artist, the album, the genre of music could determine popularity, the record label, ad spend, song length. There are a number of these things that we can track pretty easily. Release date as well. There are also a number of things that make songs popular that are really difficult to quantify. It's hard to track what instruments are used in each individual song on Spotify. Lyrics lead to a bunch of text-based messes, as well as just the tone, the energy, or what you could call the overall vibe of a song is arguably the most important attribute in whether a song is popular, but it's tough to understand what's going on there or to track that in any sort of quantifiable way. Luckily, we have a couple tools that help us. So Spotify has a really nice publicly available API that anyone can pull from, and it tracks a bunch of different stuff. It has its own metric for popularity. It can track things like the song key, the song mode, whether a song is major or minor, how loud the song is, the tempo of a song, a number of different attributes like this, as well as a bunch of custom algorithmic variables that Spotify kind of has a black box, but will output these things and say a song has this much energy, and it's scaled from 0 to 1, or this much valence, which is how upbeat the song is. And although these aren't perfect, they make pretty good proxies for understanding what sort of things are happening in a song as the song goes on. So you can do a bunch of different analyses with these, and if any of you guys are music nerds and want to learn how to do analyses on the music that you listen to, come talk to me, because I nerd out about this stuff a ton. But here's a quick example, right? You can take this data and create a quick chart on the danceability of different Taylor Swift songs by the tempo of the song. And you can find just a bunch of different interesting trends across artists, across genres, across, again, your own music that you listen to. So in order to create a model where we track whether collaboration is important or not, we're going to use popularity as an outcome variable. Spotify scales this popularity from 0 to 100, with 100 being like the most popular song on Spotify right now, right? Like I said, it's a black box. We don't actually know how Spotify is recording this or what they're using. Ideally, what we would use as a metric would be the number of streams, but that's not available via the API. You have to manually pull that down, and we use a lot of data, so that would be very intensive. But popularity is determined via some combination of the number of plays that the track has and how recent those plays are. So a pretty good metric for understanding popularity. This is important because Spotify's payout rate is about 1/4 of a penny per stream on average, which doesn't sound like a lot until you get to these higher popularity songs, right? So if we pull, again, from Taylor Swift as an example, we have her Lover album, 2 different songs right next to each other on this album. There's a 1 difference in popularity. The number of streams that each of these songs has, with that 1 difference in popularity, there's a difference of about 50 million streams, which equates to about $200,000 difference in revenue. So 1 difference in popularity can be a big deal. Notably, if you add a collaborative person to a song that you're playing, which is what we're trying to do, this revenue would then be split. So it's not necessarily helpful for bigger artists that are trying to collaborate because the revenue that you would individually get from your streams would go down. But it is useful for local artists who are just trying to get a name for themselves and therefore become more popular. So now we get to the actual model that I created, the data specifications. We're able to go into Spotify's recommendation system and basically request target popularities. So you can say I want a batch of 50 songs in this genre at a target popularity of 0, and Spotify would pull as many of those songs as it could. You can basically iterate through that a bunch of times to get a massive array of songs that we can turn into a model. So we came up with 9,852 songs from all across Spotify with 21 different genres. You can see the genres here. This isn't a great chart for seeing where each of them lie, but it led to some interesting popularity distributions between these 21 genres. Looks like popularity on the whole is either maybe normally distributed. It does appear to be kind of bimodal, with some tails at the end towards 0 popularity, depending on the genre. And then when it came to the actual model itself, this was the working through Richard's textbook and eventually getting to our stand code. We have popularity as an outcome variable, this scale from 0 to 100. The group is going to be genre that we're going to be stratifying by, because what makes a song popular for country music might be different than for show tunes or something like that. And then we're going to reduce bias by accounting for musical identity via different covariates. And these covariates are going to be a bunch of different things, but all of this different stuff that Spotify tracks, right? Whether a song is danceable, whether it's energetic, things like the key signature, stuff like that. In an ideal world, to reduce as much bias as possible, we would introduce artists as covariates as well as albums. However, my poor little MacBook Air would take too long to run that many different parameters, or that many different covariates. And so as soon as I get my hands on a supercomputer, I will run this, but not right now. This is what it looks like in the stand code. It's pretty straightforward. We've got the number of observations and then the vectors and matrices for the observations, the group assignments, and the covariates. As far as parameterization goes, we'll be using a non-centered parameterization, which is also pretty straightforward. So we take the population level parameters, the population model scale parameters, all this stuff, transform it to get a series of betas that we can use. And then the actual model itself, again, we're grouping, so we're going to be having a hierarchical linear model. I assumed normal distribution for popularity. I played around with a bunch of different bimodal distributions and found that normal accounted for popularity pretty neatly. The model was simple enough that it seemed to work fine. And based on prior predictive checks as well, normal seemed like the best choice. Priors were based off previous industry research. There are some professors who had done some similar work on what made albums popular that we were able to pull priors from, as well as just some prior predictive checks. And the model is really simple. We've got our priors, and then we've got essentially a regression model here. So what are the uses of this model? One, it allows for understanding on what makes songs popular. which is really cool. We can look at a bunch of the different covariates to see how they impact popularity. And you'd be able to do future research on this, on what different covariates are most or least impactful, as well as understanding differences across genres is key, since the industry is basically split into a bunch of different genres, and you would want to understand how popularity is impacted in your specific genre. So you could use this data for different stuff. There's a bunch of cool things you could pull from it. This is just a quick example. You could compute contrasts on this if you wanted to, but like if you're a sound engineer and you're trying to understand what constitutes a good amount of loudness for your genre in the music industry, you can pull the betas here to understand the effective loudness by genre. What's the effect of a 1 decibel increase on popularity, at least to some degree, right? Since this is a linear model, it would probably lose some credibility as you get to more extremes. But you can understand here that what the impact of loudness is for country music, for example, is very different than the impact of pop music, which is interesting. You can do similar stuff with stuff like tempo. So how does the effect of a 1 beats per minute increase on popularity, how does that vary across different genres? And so you can see that, again, you could compute contrasts in these. You can see that country music, piano music, show tunes music, interestingly, benefit a lot from faster songs than something like opera or punk music. But the primary thing that we're interested in is collaboration, right? So does having multiple artists impact popularity? Able to pull the draws from that and see that it looks like it does to some degree, right? Based on the data that we have and the model, it seems pretty likely that popularity has a very small increase, whether a song is collaborative has a very small increase on popularity of a song by about 0.5-ish is the mean, with the distribution being entirely all positive. It just cuts off very close to negative right there. You can also look at whether this varies across different genres. But as you can see, doesn't look like it varies that much at all, with maybe just a very slight increase in like country music. But on the whole, it seems like collaboration seems to slightly increase the popularity of a song. The final check you can do is you can run a model comparison, right, on whether or not the song is more or less, or whether or not the model is more or less accurate in its expected predictive accuracy, based on whether it accounts for collaboration or doesn't. So this model on the top, model 1 is the one that does account for collaboration versus the one on the bottom that does not account for collaboration. You can see that it seems to be very minorly more effective in its expected predictive accuracy. So it looks like collaborating, at least for grassroots artists, is probably a good choice. Again, you're not going to get a lot more of a revenue stream from it, but it does seem to favor Spotify's algorithm in hopefully making songs slightly more popular. It's a high probability that it's beneficial by a small margin, but when you're a small artist and your goal, Spotify has these interesting thresholds where I believe it's at 20 popularity is when it starts to recommend certain songs to you, but a song has to hit that threshold before it shows up in your Discover Weekly or whatever recommendation thing you're using. So getting a song across that 20 threshold, getting a 0.5 difference could be major for these smaller artists. Less beneficial for larger artists, again, because you'd be splitting this revenue stream. But if you're someone like Taylor Swift, you're probably making more money from concerts than Spotify streams anyway. And a really interesting, hopefully future field of research that I would like to do is being able to run similar analyses for artists on their own music, right? You can run models like this, grouping, for example, instead of by genre, by album for specific artists in order to understand, okay, what is making your songs more popular? Why are people listening to your music? And hopefully finding some interesting trends and data that artists can understand purely based on vibes and can understand more through this quantitative approach. That's it. So thanks for listening.
from my perspective, I'm wondering, so in terms of popularity, is it possible that it's affected by performances or concerts towards, I mean, like is the data impacted by performance of the song? So for example, if a small artist collaborates with a big artist, and it's possible that big artist would normally go for concerts, and that would impact the popularity of the song. So did you adjust for something like that?
Yeah, it definitely would. Having live music and bigger artists collaborating with small artists definitely would impact popularity to some degree, right? And that's the hope of a lot of small artists, is to be able to collaborate with or potentially open for a larger artist at a musical event or something like that. And then they would be able to gain a following through that from people learning about their music. In an ideal world, that would be accounted. Sadly, just based on the data that I had, I was not able to account for it. But if this were to ever turn into like some sort of actual thesis that I did in grad school or something like that, I would love to be able to find the data and run, like I said, a model that's accounting for artists specifically to kind of reduce the bias there.
Were you at all concerned with like the release date? Because it seems like if popularity score is sort of based on how recent the plays were, that more recent songs might just be benefited. But I assume that also like if the release dates were sort of spread out across your data set, it might just sort of wash out.
Yeah, so it's a great question. Release dates were spread out across the whole data set. That was something me and my professor kept a really close eye on because it could introduce a lot of, just correlated effects there. Release date was throughout the whole thing. We actually ran a model both with release date as one of the covariates and without. And the one that had better predictive accuracy was the one that accounted for release date, and so that is the model that's up here.
Yeah, what cool work, thank you. I was just thinking back to your friend and your second conclusion. I might have missed it, but what was the sort of estimate for that effect of the collaboration varying by whether you're a small artist or Taylor Swift?
Yeah. We didn't actually, there's no mathematical difference that we accounted for in the effect of collaboration there. It was more of the idea that, let's see if I can go back to it. When Spotify pays out its streams, it pays out those streams split to multiple artists that are collaborating on a song as well. So something like this estimated payout is just to Taylor Swift, but if Taylor Swift were to collaborate with Post Malone on one of these songs, then the estimated payout gets split across those two artists.
Yeah, thanks.
Mm-hmm.
I just saw an example yesterday of Dua Lipa had ripped off a riff from INXS. However, in her collaboration list on Spotify, the people that wrote the INXS song don't occur in her collaboration. So, in your opinion, if Garden Drive had ripped off a riff from Bob Dylan or something and included Bob Dylan songwriters in their collaborator list, wouldn't that increase, according to your data, your results, wouldn't that increase their popularity by, collaborating with a previously big time artist?
That's a great question and a good point as well. To be honest, I'm not 100% sure. I think that gets into the kind of weird legal thing that goes on with Spotify, where I don't know if my friend in Garden Drive legally could just automatically add one of them as a collaborator, even if he takes a riff from them. But it would be interesting to try to find examples of that and see if those are cases where popularity has greatly increased. So
there was an example where they talked about somebody reached out to Prince's estate and said, "Hey, we're going to use your music," and for some Prince, I'm just using a hypothetical, but they said, "That's fine, you can collaborate. Just make sure you put us in the collaborator list." So I think there might be a legal way to do that without doing the NXS.
yeah, that'd be cool. That's something I haven't thought of, and I'll have to go look into that for sure.